Okay, this is a lesson on graphing and evaluating special step functions. Homework tonight is in your packet, pages 29 and 30, so please write that down. And then go ahead and turn to page 26 in your packet and we'll get started. Okay, so on page 26 you see 3 graphs. What I want you to do as you're getting yourself settled is just write down what you notice and what you wonder about each graph. Okay, so hopefully for graph A, what you noticed is that there are closed circles and there are open circles. We have closed circles on the left, open circles, make this a little smaller. Oops, oh, boo-hoo. There we go. Open circles on the right, and it looks like steps. Looks like steps. Okay. And then for graph B, hopefully you know, hold on a second. Okay. So hopefully what you noticed for the graph B was that we have closed circles on the right now. Closed circles on the right, open circles on the left. Right, open on left. And again, they look like steps. It looks like little steps leading up somewhere to infinity. Okay, and then graph C has closed circles on the right and open circles on the left, and it looks like kind of stripes. I don't know. Looks like stripes. Now, for those of you who are going, oh my God, what the heck does she mean about closed and open circles? Let's talk about that for just a hot second. So when we say closed circles and open circles, these right here, these are open circles. These open circles right here, like right here, that is an open circle, And then we have these points over here that are filled in dots. They are closed circles. So these guys down here, they are closed. These guys over here, they are closed. And we call them closed circles because the points that are filled in, they are actually on the graph. So if we look at graph A, we have a point at 0, 0. It's actually there. And then we have point. But when we get to 1, 0, we really don't have a point there. That's just like a placeholder. It says everything up to 1, 0 exists. But then when we get to 1, it kind of jumps up to 1, 1. And then we have point. But then we get to 2, 1. It's everything up to that value. So that's why we put the open circle there, just as a reminder. And so what do we wonder? One of the things we might wonder is, how do we get these graphs that are not continuous? And that's something we're going to explore in a minute or two. In the meantime, let's do some evaluating. So when we look at these graphs, and we just want to do some evaluating, it says evaluate using the corresponding graph. So first we'll take a look at all the graphs on graph A. So point 3. Point 3 is probably, I don't know, somewhere between 0 and 1. And everything between 0 and 1 has a value of 0. Okay, so 2.7, we'll go to graph A. So 1, 2. Well, 2.7 would probably be somewhere here, and so we evaluate that, and it is 2. And then negative 1.4, well, here's negative 1. Negative 1.4 is going to be negative 2. So there's graph B. We're going to now evaluate those same values using graph B. So for graph B, when we go to point 3, which is like somewhere here, and we look up at the graph, we see we have a point at 1. 2.7, which is about right here, we go up and we have a value at 3. Negative 1.4, negative 1, and then the 0.4 would be like here, has a value of negative 1. Okay, Now, graph C is a little tricky because we see we have these nice diagonal lines. So what we notice is that for 0 to 1, like if this was 1/2 right here, its value would be 1/2. But then at 1.5, its value is 1/2. At 2.5, its value is 1/2. At 3.5, its value is also 1/2. So what I'm noticing is that I only have y values between 0 and 1 for these positive values, and for the negative values, I only have values between 0 and -1. Like if I go to -0.5 on x, I have a y value of -0.5. So what do you think is going to happen if we put in 0.3? Well, what happens is we get 0.3 right back at us. But when we go to 2.7, 0.7, its value is somewhere between 0 and 1. Where do you think it is between 0 and 1 for 2.7? If you said 0.7, that's correct. 0.7. Now, -1.4 is a little trickier. Here's -1, and then 0.4 would be like somewhere here. And its value is somewhere between 0 and -1. So where do you think -1.4 would fall if you followed these patterns? It will be at -0.4. And we're going to talk about that. So what does all of this mean? Well, how do we describe these graphs? What we have done for graph A, 0.3 became 0, 2.7 became 2, -1.4 became -2. What we are doing for graph A is we are rounding down to the next integer. And for graph B, we had 0.3 became 1, 2.7 became 3, -1.4 became -1. We are rounding up to the next integer. Now for graph C, this one is my favorite, I have to tell you, because I get to be like, we're going to hack it. So literally what we are doing is we are cutting off the whole number and keeping the decimal or fraction. Because if it was like 2.5, we'd cut off the 2, we'd keep the half. And these are called special step functions, these three functions, because duh, they look like steps. That's why we call them special step functions. Yay! All right, as soon as you're done writing that down, do a dramatic flip to page 27. All right, page 27. So now what we're going to do is we're going to complete the chart. So for graph A, we are rounding down. Now, here's the tricky thing. Mathematicians like to be a little tricky sometimes. So even though we are rounding down, we are calling this function the greatest integer function. And it is because it is the greatest integer that is less than or equal to x. What's the biggest number we can use? The biggest whole number that we can use to represent x. Now, honestly, I'm not going to call it the greatest integer function because that confuses even me. I like to call it the round down function. There's another teacher here, she likes to call it the floor function, so we'll, also call it the floor function. But Ms. Strauss likes to call this the round down function because that's what you do. You round down. So if this is the round down function and this is the greatest integer function, I want you to take a second and predict, what do you think we call graph B? What's the opposite of greatest integer? Least integer, because it's the smallest integer. Well, not really. It's going to be the smallest integer that's greater than or equal to x. Okay, I'm really not going to call it that because I find that to be confusing. I'm going to call it the round up function because that's what we're going to do. Like if we have 0.5, we're going to round it up to 1. If we have 2.5 or 1.5, we're going to round it up to 2. For graph A, our round down function, over here we have 3.5. 3.5 rounds down to 3. Okay? Now, my favorite graph, the little slanty stripes, graph C, is called the fractional part function. It's the fractional part of x because we are only keeping the fractional part. And its nickname, I like to call it the chop it off function because we are going to cut off the whole number and only keep the decimal or the fractional part. Okay? So how do these functions look in function notation? Now, this is what I need you to copy down really, really carefully because they're going to look a little similar, especially for the round down and the round up. So I like the way the round down function looks because it kind of makes sense. So we've got the round down function, and it kind of looks like square brackets, but there's no top part. Okay, it's got just like a little ch-ch and a little ch-ch. And then the ceiling function, the round up function, I like the way that one looks too because it kind of makes sense because it's the brackets, but only with the top part of the brackets. And then for the fractional part of x function, it's going to just be the set notation brackets. So make sure you have those copied down exactly as I do. Okay, so the definition for the round down function is we are just going to take the greatest integer that is less than or equal to x. For the least integer function, we are going to take the smallest integer that's greater than or equal to x and take the fractional part of the number. Again, for the round down and the round up function, I don't want you to stress out about these definitions. If you look at this notation and you're like, oh yeah, if I have 4.8, that becomes 4 on the round down function, but this one, the round up function, 4.8 becomes 5, that's all you need. All right. So the domain and the range. Let's take a look at these. When we look at the domain, do they stretch from left to right? Yes. Does graph B stretch from left to right? Yes. Does graph C stretch from left to right? Yes! What is the domain? Shout it out! All real numbers! So literally, all real numbers, all real numbers, all real numbers. Right. But then we talk about the ranges. When we look at these graphs, what do you notice about the range of the round down and the round up? What kind of numbers are we going to get? If we're going to round down to the next integer and round up to the integer, all of our y values have to be integers. Okay, but for the fractional part of x, if we're going to chop off the whole number and just keep the decimal, our range is going to be anything between -1 and 1. And you can put a y here. I actually don't like that. That's confusing. Let's make it a y. There we go. Ha! Y. And notice that there's not equal to signs. All right. So the zeros, the x-intercepts. Okay, now I want you to notice that for the round down function, we're including 0 but not 1. And for the round up function, we are not including -1, but we are including 0 because that's where these graphs touch the x-axis. And then the y-intercepts are 0, 0, and there you go. Right. Now, what I really want to focus on is that number 5 at the bottom. So I want everyone to take a look at number 5 at the bottom of page 27. And I want you to take about 30 seconds and fill in those 8 and see what you can get on your own. Go. Timing you. Fifteen seconds. And take your last guess. All right, letter A. So when we look at letter A, we see that we've got the brackets are on the bottom, and that's super awesome because it's going to tell us to round down. 3.9 rounds down to 3. But letter B has the brackets on the top. So 1.6 is going to round up to 2. And now, guys, this is where we're not going to use 5 and above, give it a shove, 3 and below, or 5 or 4 and below, let it go. We're going to follow the brackets. So even though the 0.9 would normally tell us to round up, we have to pay attention to the brackets. Okay, so just FYI. All right, so here we go. Letter C is a chop it off function. So we're just going to chop it off, and it just is going to become 0.1. Letter D is a round up function. Now, this is where life could be a little confusing because it's a negative number. If you wrote -3, you were kind of on the right track, but let's make a fast-o number lino. If we've got 0 and then -1, -2, -3, negative 2.5 is right here. So if we round up, because see how the bracket's on the top, we're really rounding up to negative 2 because that's actually a bigger number. So just be careful. So negative 4.2, similar situation. We see the brackets tell us to round down. But again, if you need to make a super fast number line, negative 1, negative 2, negative 3, negative 4, negative 5. So negative 4.2 would fall like somewhere here. Whoop, hey, what happened? That was weird. Like somewhere here. And then if we're going to round it down, rounding down takes us to negative 5. Okay. Letter F is a chop it off function, so it's just going to be negative 0.7. Letter G is a round down, and it's a positive number, so it's just going to round down to 8. And the letter H is a round up function, and it's a positive number, so it will round up to 7. Cool beans. Everybody flip to page 28. All right, on page 28, we have 3 functions, and we need to describe the transformation. And we're going to use the same words we used before: up, down, right, left, flip, stretch, all that fun stuff. But the first thing we want to do is we want to identify what do we have. So I'm going to look at my holes. So I noticed that letter A starts with a closed circle. So everybody fly back to page 26 super fast. So which one starts with the closed circle on the steps? Yeah, the round down function. All right, so as soon as I realize that, I'm going to make a little noto here that this is a round down function. So its notation is going to be like the rounding down. Okay. And then for letter B, well, if this one's a round down, this is a round up. Because we're going to round everything up, so it's going to be like that. And this one starts with closed circles. It's also a round down. Okay, so describe the transformation. Well, let's flip back to page 26 because these are new functions. So page 26, I know that my round down function has a closed circle on 0, 0, so that's like my shift point. So we'll see where we have, if we have a point at 0, 0. No, we do not. There is no point here. But I got one down here. So the transformation is down 2. So if our transformation is down 2, the equation is going to be like a k value of minus 2. So it's going to be y equals round down function minus 2. Cool. All right, now let's take a look at our round up function on page 26 to see where like our 0, 0 point and what it looks like. All right, so I look over here and I notice that the 0, 0 point for rounding up is a closed circle and it's at the end of the step. So like for graph A, it was the closed circle at the beginning. So let's see, where do we have a closed circle at the end of a step? It's right here. It's up 2. So for the round up function, letter B, we're going to have y equals round up plus 2. All right. So graph C, I still have that point 0, 0, so that's a bonus. I know that it's not going up or down, but I noticed that my steps are really far apart. Like if Miss Strauss was trying to climb these steps, it would be a struggle, man. It'd be a major struggle with her short legs. So what we have here is we have a vertical stretch by a factor of 2. And sometimes we have this with quadratics, like it would be like a super skinny parabola if it was like 2x squared. The equation for this one, well, it's a round up or round down. We're going to have y equals, this is our a value. This is our slope. So we're going to have 2 round down x. Awesome. So what I want you to do is look at the bottom of page 28 and look at the 3 functions, and I want you to take about 30 seconds is I want you to describe what kind of function it is and what the transformation is. I'll give you a hint. Each one of them has only one transformation, and then we'll graph them together. So take 30 seconds and go. "15 seconds. Okay, so your 30 seconds is up. So when we describe graph A, it's going to be a round up function, and it's going to go to the right 1. And that's going to be just like if it's like x minus h, and it's the opposite of what we see inside. So everybody flip to page 27 and take a look at that round up function. And I want you to notice that the round up function at 0, 0 looks like this. Oops, h. Round up looks at 0, 0, I've got a point, and then I've got a point over here, and I got this little step. What we're going to do is we're going to take that one little step and we're going to move it to the right 1. So the whole circle, the closed circle at 0, 0 becomes a closed circle at 1, 0, and then an open circle. Once I've shifted that little step to the right 1, I just continue the pattern, because it's already gone to, everything will get put to the right 1. All right, so for graph B, hopefully everyone wrote down that this is a round down function, and it goes up 1. Because it's a round down function, everyone look at page 27. Graph A, a round down function starts like this. Okay. So, and it goes up 1. So I'm going to take this piece that I have graphed here, and I'm just going to move it up 1. And then I'm just going to continue the pattern. Okay. So then we go and we look at letter C. Letter C is also a round down function, but because it's got that negative out front, it's going to flip over the x-axis. This is going to require a little more planning. Everyone go ahead and look at the round down function, which is graph A, on page 27. Let's go look together. Okay, so here we go. Here's page 27. Here's my round down function. So what I see is I'm going to take this whole graph and I'm going to flip it over the x-axis. So this line right here, I'm going to do a little highlighting. This is not going to change. So everybody flip to page 20, go back to page 28. We're going to keep this point where it is. But now the difference is, instead of the steps going up, the steps are going to go down. So let's try it. So on page 28, we're going to have our point, oops, just like the original one. It's going to look rounding down, point here, open circle. Now we're going to flip them. So instead of having closed circle to open circle, we're going to have closed circle to open circle, and then we just got to continue it. All right, homework tonight that you may start right now are pages 29 and 30. Now I'm going to tell you, you will need to keep referring back to page 27 to keep track of which function is which. That is going to be a little tricky to start. So everyone go ahead and get started on page 29 and 30.